The major operation here is I'm going to attempt to machine the underside of the tailstock base plate. It's worn on the leading edge and the trailing edge and rocks front to back on the bed of the lathe. Now this would be a simple operation on any milling machine, but in the spirit of trying to fix everything on the lathe itself, I'm going to attempt to machine the base plate on the puny little milling attachment that comes with the lathe. The idea being to skim about 5 thou off the bottom. Now there are two major problems with doing an operation like this in a small milling attachment. Firstly, the milling attachment doesn't have a level base in any axis, so the work has to be dialed in all three axes, which is a pain in the ass. The second problem is that the whole setup is just flimsy. There's a huge risk that with heavy machining on cast iron or steel or whatever, there's a pretty good chance that milling bit is going to catch the work and then something's going to give. And I just quickly check all four corners before making a final skim pass. You come across these small dome head pins on all sorts of nameplates and decals or machinery. First time you come across them, of course, you'll try and rip them out with pliers, pry them out with screwdrivers, and once you just completely destroy the whatever it is you're trying to remove, you'll figure out the secret. Now, these pins have a fluted spiral to them. Not so much a screw, more like a drill bit. With the scribing of the brass plate complete, I moved my attention back to the tailstock itself. Now this was acting a little strange. The parts get a quick spray with degreaser, and the smaller pieces I throw straight into the ultrasonic cleaner. Check out the crustiness under the original paint. Because of that crustiness, I soaked this and a bunch of the other parts in citric acid for a couple of hours just to get ready for paint. Now, Myford did not apply their paint directly to cast iron. First, the machine was sprayed with some sort of self-leveling spray putty. They sprayed it on pretty thick. Now, to replicate that finish, I'm not going to use spray putty. It's too unstable. What I'm going to do instead is use this green spot putty, which is designed for filling tiny pinholes prior to finishing paint on automotive resprays and things like that. So completely smearing spot putty over an entire piece is not what 3M designed this product for. However, I've used it quite a bit in the past and I'm sure it will be fine. At some point in the past, a moron decided that Myford's scribed scale was insufficient and decided to extend it with a hacksaw. The only way to properly fix the problem would be to weld up the mess and remachine the part. The chances of being able to do that without taking any material off the rest of the barrel are pretty slim. I'm going to attempt to get it at least presentable. I'm not going to spend any money on it, so I'm just using what I have in the cupboard already, which is a 2-part metal epoxy. At this point it dawned on me that you guys hadn't given up your precious time just to see some chump fill something with epoxy, so I decided to redo it semi-properly. This is actually aluminium filler, which of course won't stick to steel at all. But as you know, lots of things that don't work actually work pretty well in the real world. In saying that, it did take a few passes to go back and fill in all of the little holes. Now the next step is to compensate for the 5 thou that I shaved off the bottom of the tailstock base. To do this, I'm using 5 thou thick brass shim sheet. And to hold it on, I'm simply using super glue. Super glue is great because it'll never let go unless you want to get it off, and then it peels off fairly easy. This means the base of the tailstock is effectively infinitely renewable. I realise there are proper products out there for relining slideways. Brass sheet this thin costs almost nothing, and it's reversible if necessary. And here I'm simply roughing up the base of the brass so there's some space for oil.